Let me start today by just doing a quick review question to kind of test your knowledge, your recall of the information that we talked about in the last class. So this is just one of those questions that I've attached to Blackboard. It's number 2. So which of the common problems in the construction of the CPI, we talked about 3 of them, might be illustrated by each of the following situations? The invention of the iPod. This is an old problem, I guess. Haven't changed it in a while. Which of the 3 problems or biases, we call them, would affect the CPI in this case, the invention of an iPod? Bias. There was what? The introduction of new goods. And there was, what was the third one? Unmeasured quality changes, right? So the first example here would obviously be what? Sean? Introduction of new goods, right? How about the introduction of airbags in cars? So airbags weren't always in cars, right? Which problem might that be affected by in the CPI? Go ahead, second row. Sorry? Yeah, changing the quality of a good. Good. C, increased personal computer purchases in response to a decline in their price. Neff? That's a substitution bias, right? Remember, the substitution bias occurs when the relative prices of goods change and people start moving away from relatively more expensive goods into cheaper goods. D, more scoops of raisins in each box of Raisin Bran. Substitution, new goods, quality improvements. That would be an example of an unmeasured quality change, right? The BLS tries to incorporate these quality changes by adjusting the prices that they see when they're recording prices in the field, but it invariably misses some of them. And so the increases in the cost of living as reflected in the CPI don't fully account for these changes in quality. How about the last one there? Greater use of fuel-efficient cars after gas prices go up. Sean? That's the substitution bias, right? You substitute away from gas-guzzling automobiles to more fuel-efficient ones like electric or hybrid cars, right? The CPI is not going to pick up that substitution very quickly. Why? Because the basket of goods that is used to construct the CPI is fixed over a period of years. Okay, I think you guys got the hang of that. I wanted to talk about those issues though, because very similar to our use of GDP as a measure of the overall health of an economy or the total level of economic activity, GDP is in a lot of ways just an imperfect measure of how healthy an economy is. Well, the CPI is also a somewhat flawed measure of the cost of living. And so I think it's important that you guys be able to recognize what those distinct flaws are, right? There's substitution bias, unmeasured quality change, and this idea that new goods enter the market regularly. Okay. All right, so we really only have 2 kind of subtopics to discuss today. Should have plenty of time to do it. The first one that I talked about quite a bit in the introduction of this particular section of the course was the idea that the CPI helps us be able to compare dollar figures at different points in time. Okay, sometimes economists or policymakers want to make comparisons between the real kind of purchasing power of some dollar amount from the past and compare that to the present. Okay, well, how do we do that? That that task is going to be complicated by the fact that over time, the prices of goods and services tends to go up because of inflation, okay? Well, fortunately, we can use the consumer price index to make the proper adjustments so that we can do a valid comparison between historical dollar figures and what we actually see in the future. All right, now there's lots of different examples of how we could do this. All right, but I think for this class, given that it's a macro principles class, I would like to talk about it in the context of something, a policy that is important for macroeconomics, and that is the minimum wage. Okay, and we'll actually come back and talk a little bit about the minimum wage later in the semester when we discuss unemployment and the labor market. All right, that's a big topic in macroeconomics. So the basic question I want you guys to think about over the next several minutes here is whether or not the federal minimum wage today has more real value than it did at a particular date in the past. In other words, what is the purchasing power, that is the command that the minimum wage had over real goods and services at some point in the past, equivalent to, greater than, or less than the real value of the minimum wage as it is today, okay? And so that's the example that I want to work with. I'm going to pick the year 1964, okay? You guys might not realize this, but in 1964, the federal minimum wage was $1.15, right? My dad worked at a hospital, an Army hospital, when he was a teenager, I believe, and told me that he made $1.15 an hour, the minimum wage during the time. In 2019, so this is going to be the most recent year that we have a full year's worth of data, the minimum wage was $7.25. Now, let me be clear about this. This is the federal minimum wage, right? There are lots of states and cities, actually, that have minimum wages that are much higher than $7.25 an hour. In Alabama, I don't think we do. I think $7.25 is the federal and the state minimum wage. But I think in California, New York, Seattle, I think, has like a $15 minimum wage. So in some parts of the country, it's considerably higher, okay? This is the basic concrete question I want you guys to think about. When was the federal minimum wage, the real value of that minimum wage, greater? In 2019 or 1964? Now, we obviously can't just compare $1.15 to $7.25, right? That's a completely invalid comparison. Why? Because $1.15 today buys far fewer goods and services than it did in 1964, because inflation is driving the value of our money lower over time, okay? So what we need to do here is figure out some way of converting this past dollar figure into an equivalent current dollar figure amount, all right? And then we can make the comparison. Did the real wage in 1964 have more purchasing power or less purchasing power than the federal minimum wage today? So that's what we have to do, is somehow use the CPI to convert this past dollar amount into some equivalent measure of quote unquote today's dollars. The CPI is very useful to do these types of conversions, all right? Now, how do we do it? Well, it's quite easy, okay? You guys can just plug this into the formula here, and I think once you read this, you'll kind of get an intuitive sense about why it's true. So if we want to take some dollar figure from a past time, and we want to figure out what the equivalent current value of that amount is, you plug it into the following formula. So take the amount in year T. I'm just going to denote that as the past dollar amount. So in our example, year T is 1964. And you want to multiply that times the following ratio. The price level today divided by the price level from year T, that is in the past. That's going to give you the equivalent amount in terms of today's dollars that the past dollar figure would be equal to, right? Now, I think it makes sense why we multiply it by this ratio. Effectively, what are we doing here? We're inflating a past dollar amount by a factor that is equal to how much the price level has gone up from year T, the past year, to the present year. Okay? Now, the variable that we're going to use to measure the price level or the cost of living can be something like the CPI. You can do the same thing with the GDP deflator, by the way. Okay, so in our example, year T is 1964, and today will be 2019. The minimum wage in year T, or 1964, was $1.15. Now, here's the data that you need. The CPI in 1964 was 31. The Consumer Price Index in 2019, so that's the last year that we had a full year's worth of CPI data, was 255.7. So you can see here just the difference between these two numbers. The prices of goods and services has risen dramatically over the past several decades, right? This information is going to help us figure out how much we need to inflate the $1.15 amount to get some equivalent current dollar amount. Okay, so we plug this into the formula, and we find that $1.15 times the ratio of the CPI today, that's 255.7, divided by 31, that's the CPI from 1964. If I did the math right, this is $9.49. Okay, now let me stop there before we answer our initial question. Who can interpret this number for me? What does this mean? That's not the minimum wage today, but rather, Sean, what does it mean? That's right. So in other words, the amount of goods and services that $1.15 could buy in 1964 is equal to $9.49 today. Alternatively, $9.49 has the same command over actual goods and services today that $1.15 had over similar goods and services way back in 1964. So, has the real value of the minimum wage gone up, down, or stayed the same according to our little conversion here? It's gone down, right? The minimum wage today is only $7.25. If the minimum wage had been increased over time at just the rate of CPI inflation, the minimum wage today should be equal to $9.49. Then they would have equivalent real values. But in fact, the minimum wage is significantly lower than $9.49. This, by the way, is one of the primary lines of argument that policymakers use to try to promote increases in the federal minimum wage, is this idea that the minimum wage hasn't even kept up with basic inflation. Okay, and so we need to raise it at least to this level, and is also why many states and municipalities have increased their own minimum wages well over the federal minimum wage. So Alabama is far behind in that particular movement. There are folks who are, in favor of raising the minimum wage. Some people actually believe in eliminating the minimum wage altogether. I'm not going to wade into that discussion, but the fact of the matter is that the real minimum wage today is less than it was way back in 1964. Y'all have any questions about that? Before I go on to the next slide, there is on the BLS website, they have this thing called an inflation calculator that allows you to do these kinds of comparisons for any dollar figure and for any set of years. Let me just show you guys that real quick. So here, you can find it on the Bureau of Labor Statistics website. It's called the CPI inflation calculator, right? So let's say you guys, Sean, you graduate from college, and your first job, you make $100,000 a year. Okay, so that would be, and we'll just say that's January of 2020. how much was that $100,000 worth, let's say, in the year you were born? Sean, what year were you born? What year? I'm getting old. By a show of hands, was anyone in here born in the 90s? 2 people. Okay. My own son is closer to you guys' age than you all are to me. That makes me really feel old. Okay, what year did you say, Sean? 2001? Okay, so from January 2020, $100,000, what would be the equivalent value the year you were born? $67,000, $67,875 a year. So you see that over just your lifetime, inflation has caused the real value of our money to actually fall. And so you need much more today than you just needed 19 years ago in order to have the same real value over goods and services. And by the way, that's in a country that has pretty low and stable inflation, right? The United States, for the past 40 years now almost, has been very successful at keeping inflation around about 2% per year. That's historically quite low. So you can imagine how big of a gap between these numbers you would see in countries that have experienced much larger rates of inflation. Later on in the semester, we'll spend a whole chapter talking about the relationship between the money supply and inflation. And we'll talk specifically about some countries that are experiencing what's called hyperinflation, right? This is a dramatic, tremendous level of inflation of like over 10,000% per year, and the destruction that can have on an economy. Okay, now it's time for you guys to do some work. And this one should be near and dear to your hearts, or perhaps your parents' hearts. Here is an active learning exercise that gives you some real US data on the cost of going to college per year. So what you have in the rows here are the average, so these are the nationwide average tuition and fees annually at 3 different types of US colleges. So private, nonprofit 4-year colleges, universities, public 4-year institutions like us, and then community colleges or 2-year colleges. So in 1990, for example, private 4-year college tuition and fees was $9,340 per year. In 2019, it was closer to $37,000 per year. If you guys want this data, by the way, I've got the website that you can get it from. And here are the figures for public 4-year colleges and public 2-year colleges. Here's what I want you guys to do over the next several minutes here on the next slide. I want you to first express these tuition figures that are in 1990 in terms of equivalent 2019 dollars. Okay? In other words, use the data on the CPI, which is right here in the bottom row, by the way. So it was 130.7 in 1990 and 255.7 in 2019. And I want you to first tell me what college tuition for each of these 3 categories would have been in 2019 if tuition and fees had just increased at the rate of CPI inflation. Spoiler alert, it increased by a lot more than the rate of CPI inflation. So the second thing I would like you to do then is calculate the percentage increase in the real cost of college. That is, what is the equivalent 2019 tuition compared to what tuition actually was in 2019? Yeah. You can just round to maybe the first decimal point. It's sufficient. So why don't you guys take a few minutes and place that information on the table on the next slide there for me, right? So there should be spots here to put the inflated or equivalent 2019 values for tuition, and then you can compute the percentage changes between the actual 2019 price and what the 2019 price would have been had it just increased at the rate of inflation. Let me give you guys a few minutes to at least start on that, and then we will compare answers. This is the type of application of the CPI that I hope you would be able to demonstrate on an exam, for example, okay? So being familiar enough with the concept to solve an application that you might not have seen before. Okay, anybody want to give me a hand here? Anybody get an answer for what private four-year colleges would have cost in 2019 had this tuition rate that we observed in 1990 simply gone up at the rate of CPI inflation? I don't remember. What's your name again? Alex. I knew that. Go ahead. Say it a little bit louder for me. There you go. $18,272 and change. And Alex, did you get this for the percentage change? About 102%? Okay, do you guys see where those numbers came from? So this 18,000 number, that's 9,340 times what? Times 255 divided by 130. That is the ratio of the CPIs, right? And then Alex, I'm assuming you got this 102% number by computing the growth rate between these two numbers, 18,000 and about 37,000, right? So what we see here is that tuition at private four-year colleges, real tuition, not nominal tuition, but real tuition has essentially doubled since 1990. It's gone up by about 102 percentage points, 102% rather. So well in excess of CPI growth, that is the average rate of inflation across the economy. What about public four-year colleges? What would tuition look like today if public four-year tuition, which was $1,900 in 1990, simply went up at the rate of CPI inflation? What's your name again? Go ahead. About $3,733. Good. And I think I did this right. That means that real four-year college tuition has gone up a whopping 180.7%. So in contrast to what the average guy on the street might think, tuition has gone up at public four-year colleges at a much quicker rate than it has in private four-year colleges. Yeah, tuition today, and again, this is nationwide average tuition, is 10,000 compared to about 4,000, which is what it would have been if it had just gone up at the rate of inflation. What about community colleges, two-year colleges? Anybody get a number for that one? No? Back row? I think I heard 1,772. Good. So community colleges, their real tuition has increased by 110.5%. So in fact, among all three categories of US colleges, private four-year colleges have experienced the least real tuition inflation. It's gone up a lot, but not as much as public four-year colleges or even two-year community colleges. Very good. You guys have any questions then about that? I like these type of problems, okay, because they really test your understanding of the concept. You have to know what the CPI is, recognize that the CPI can be used to compare dollar figures at different points in time, and then you're correctly applying the formula, all right? Let me move on then to the last topic that I want to talk about here, and that is differences between what we refer to as real versus nominal interest rates. So to tie this back to our discussion from a week ago, hopefully you guys remember that inflation distorts our understanding of gross domestic product. It distorts our understanding of how much income and output a country produces, because it obscures or drives a wedge, if you will, between two different GDP concepts, real GDP versus nominal GDP. Well, it turns out that inflation also distorts other macroeconomic variables that are important and affect our everyday lives, okay? One of the most important macroeconomic variables has a big impact on our own standard of living, and the decisions that we can make are in fact interest rates, okay? Now let me stop here for a second. I don't want to presume anything. What is an interest rate? This is a principles class after all. What exactly is an interest rate? Just conceptually. or an interest payment, rather. Matt? Yes, so it's a payment that one makes in the future for some amount of lending or borrowing today, right? Or alternatively, if you're the lender here, Matt, it's the payment that you receive in the future for making those funds available to a borrower today, okay? Now, by its very definition then, interest rates are going to link together current borrowing to future payoffs, right? There's the exchange of funds happens today, but the payment for that exchange actually doesn't happen until the future. That's what the interest payment is. So what can happen in the intervening period between when the loan is first made to when the loan is paid off with interest? Well, in that intervening period, however long it is, it could be a year, it could be 5 years, it could be 30 years. If it's a mortgage, prices of goods and services will change, right? Will probably go up because of inflation. What that means then is that inflation is going to affect the real value of the interest rates that we pay if we borrow or that we receive if we're lending. So where inflation distorts our understanding of GDP, it can also distort our understanding of what the actual interest rate is in any borrowing or lending transaction, okay? Now, the nominal interest rate is the interest rate that I'm sure you're probably more familiar with. This is the interest rate that is not corrected for inflation, okay? It's simply measures the rate of growth in the dollar value of a debt or a deposit, okay? This is the interest rate that a bank would quote you on a loan or on a savings account, right? And by the way, interest rates can differ from one loan or one savings instrument to another. There's not just one interest rate, right? There's probably thousands of different interest rates in the US economy. The real interest rate is something different. This is corrected for inflation. And instead of measuring the growth rate in the dollar value of a deposit or a debt, what it does is it measures the growth in the purchasing power, the real purchasing power of a debt or a deposit. Now, fortunately, the real interest rate and the nominal interest rate are closely connected by a simple formula that simply adjusts for the rate of inflation, all right? And here's what that formula is that you'll need to know. The real interest rate is simply the nominal interest rate minus whatever the inflation rate was that prevailed during that loan period, right? So however much prices went up from when you first deposited your money to when you withdrew your money, that's going to affect the real rate of interest that you receive. Let's do a simple example to illustrate what we're talking about here. Neff, let's suppose that you deposit $1,000 for 1 year into some type of savings account, okay? And that account is going to pay you, agrees to pay you at the beginning of this payment period, a nominal interest rate of 9% annually. All right, now that's a high nominal interest rate compared to what most people are used to these days. But we're just going to do this as an example. Okay, so what does that mean then? Let's suppose that during the year in which you have deposited your $1,000, that inflation ends up being 3.5%. What we want to know is, what is the real interest rate on this particular savings? Well, it's just the nominal rate minus inflation, right? So what is the nominal rate in this example? It's the 9% interest that the bank is quoting you. Inflation is 3.5% over the intervening year, meaning that the real interest rate is only 5.5%. Now let's make sure we understand why this is the case. Neff, if your interest rate is 9% and you deposit $1,000 at the beginning of the year, you're going to have $90 additional dollars in that account at the end of the year, right? So your account will go from $1,000 to $1,090. That's a 9% increase in the dollar value of your deposit, or a 9% interest rate. However, over that year period, inflation has actually eroded the value of your principal deposit by 3.5%. That is by $35 out of the 1,000. So simply by having your money tied up in that account for a year, the real value of your deposit has gone down by 35 bucks. The net effect of the nominal interest rate and the decline in the real value of your deposit due to inflation, that is $90 minus $35, is a $55 increase in the purchasing power of your deposit. In other words, a 5.5% real interest rate. That's the basic intuition behind it, is to recognize that over time, inflation is going to erode the real purchasing power of any debt or deposit you might have. And that needs to be accounted for when computing the real interest rate. The real interest rate is the economic variable that matters more for investment and savings decisions. Okay, last picture I want to show you here is some actual US data on real and nominal interest rates since actually 1950. The blue line is the nominal interest rate. Now this is the interest rate on a particular asset, and that is the 3-month Treasury bill. So these are very short-term bonds that are issued by the federal government, by the US Treasury Department. This shows the annualized interest rate on those bonds over time. Sean, you need me to go back to us? This picture looks different than what you're seeing? This one looks different. How does it look different? Oops, okay, well then I made a mistake. Is that on everybody's slides? Did I screw that up? Yeah, okay. I don't know why I did that. I've got 2 sets of slides. One are the lecture slides, one are your slides, because you guys fill them in. I must have neglected to, I can update them and send them out. Okay, so ignore what is on your screen and just look at my screen for a second, okay? So the blue line is the nominal interest rate. The red line is the real interest rate, computed as what? The difference between the nominal interest rate and the rate of inflation over that period. Let me ask you a question about this graph. You'll notice that in early 1950s, the late 1950s, for much of the 1970s, and really most of the past 10 years at least, the real interest rate in the United States has been negative. Well, how can that be? How can we have a negative real interest rate? Back row? That would be exactly why, right? In this period here, between about 2008 through 2016 or 17, you'll see that the 3-month Treasury bill interest rate was basically 0%. Short-term nominal interest rates in the US economy have been really close to 0 for quite a while now. However, inflation was not super close to 0. It was somewhere around 2%, right? And so the real interest rate fluctuated 1 or 2 percentage points below 0. So it is not uncommon at all to have negative real interest rates, meaning that if you deposit your money in an account with a negative real interest rate, that deposit is going to have less real purchasing power at the end when you take it out, okay? Another question. Do you guys notice any type of relationship or correlation between the blue line and the red line over time, or perhaps where that relationship kind of suddenly changed? Take a look at before 1980, particularly during the 60s and 70s. What do you notice generally happening to the nominal interest rate compared to the real interest rate? Looks to me like the nominal rate goes up and the real interest rate trends down for much of that time. Why is that? What does that imply? What's the difference between these two lines? Sean? Yeah, literally it is, right? If the real rate is the nominal rate minus inflation, then just swing that equation around. Inflation is the nominal rate minus the real rate, right? So in other words, it's the difference between the red line, the blue line, and the red line. And so if those two lines are getting farther apart, that shows that inflation is growing and it looks like it's getting more volatile, which is of course exactly what you see on that graph that you were looking at a minute ago, right? During the 60s and 70s, inflation in the United States and in most other major developed countries got really high and volatile. What do you notice after 1980? The blue and red line are sort of parallel, right, and trending down, meaning that inflation got lower and much more stable over time. So the behavior of inflation in the US economy changed dramatically in the late 1970s through the early 1980s. It was not uncommon at all for inflation to be close to double digits during the 1970s, whereas now we're more likely to have deflation than we are to have high and variable inflation. Let me ask you guys one more question, and then I'll let you go early today. Take a look at this fourth one. Suppose that a borrower and a lender agree on the nominal interest rate to be paid on a loan. Then inflation turns out to be higher than both parties had expected ahead of time. Part A, is the real interest rate on this loan higher or lower than expected? So if inflation ends up being higher than what we thought, so let's say I agree to loan Matt $10,000 at a nominal interest rate of 5%. So at the end of the year, he's going to pay back the $10,000 plus 5% interest. And let's say we both expected inflation this year to be 2%. What happens, however, if inflation was 3%? Let's say it was higher than we'd expected. What happens to the real interest rate on this transaction between Matt and I? Go ahead. That's right. So what was the real interest rate when we made the arrangement? It was 5% minus 2% or 3%, right? But if inflation goes up to 3%, then the real interest rate goes down to 2%, right? Okay, so higher than expected inflation lowers real interest rates from what they were expected to be. The math is pretty straightforward. Let me ask you the follow-up question here. Does the lender gain or does the borrower gain from this sudden change in expected inflation? Who loses and who wins here if the real interest rate ends up being lower than what Matt and I had implicitly agreed to? Sean? The borrower is going to gain. Why? The borrower gains because he's paying back at a lower real interest rate than what we had agreed to. In other words, he's paying me back with dollars that are less valuable than what we thought they were going to be, right? The creditor or the lender is the one that loses because I'm receiving a real interest rate that is now less than what I thought I would have received, okay? This is one of the biggest kind of social costs to sudden unexpected inflation. It's really helpful for the financial system, for borrowing and lending, if borrowers and lenders can have pretty reliable expectations about what inflation is going to be. So if inflation is low and very stable, and it's not going to fluctuate too much from 2%, that's going to promote more borrowing and lending because we can have confidence that the real interest rate is going to be basically what we thought it would be ahead of time. But in economies where inflation bounces around a lot, and there's a lot of unexpected inflation or deflation, then real interest rates are going to change around a lot. And what that does is that creates winners and losers, right? If there's higher than expected inflation, the borrowers gain at the expense of the creditor. If inflation turns out to be lower than expected, it's exactly the opposite. The lender gains at the expense of the borrower, right? So here's an applied real-world example of that very principle. Inflation during the 1970s, as you know, was much higher than most people had expected when the decade began. How do you think this affected homeowners who obtained fixed-rate mortgages during the 60s? And how did it affect the banks that lent the money? So who gained during the 70s as a result of the higher than expected inflation? Homeowners did. Homeowners that locked into fixed rate mortgages in the 60s ended up paying off those mortgages with dollars that were less valuable, that is, with a lower real interest rate. Banks, on the other hand, suffered much heavier losses because the real interest rates that they were receiving were lower than expected. It is not surprising at all then that by the mid to late 70s, a lot of banks and lenders were starting to promote not fixed rate mortgages, but adjustable rate mortgages as an alternative product, right? Adjustable rate mortgages will go up over time if inflation starts to go up. Now, if inflation starts to go down, adjustable rate mortgages are also supposed to go down. I don't particularly like adjustable rate mortgages, but that's really when they became more popular, when banks started to offer them more, is because after they'd suffered these huge losses during the 70s. Yeah. Well, during the financial crisis, it was really instigated by a bursting of the housing market. That is true. But ever since then, inflation has been actually a little bit lower than what people probably expected ahead of time. So to that extent, it probably increased real interest rates more than what we might have expected. So I don't think the same type of problems that we saw in the mortgage markets in the 70s with high and variable inflation, that's a different set of problems than what was happening during the 2000s. During the 2000s, the problem was, in my opinion, there's still debates on this, is that mortgages were being provided in huge volumes to customers that didn't really have the means to pay them off. This is a more complicated answer than you probably want, but in our economy, when you take out a mortgage, let's say from a bank, the bank doesn't just hold that mortgage as you pay it off forever. What they essentially immediately do is they turn around and sell that mortgage to another group who combines those mortgages from lots of different people, and they sell it as an asset, okay, as what's called a mortgage-backed security. Well, when a bunch of people start to default on their home loan obligations, the value of those underlying assets crash. And that's ultimately what caused the financial system to freeze up completely. Those are somewhat more advanced topics than a principles class, but if you're interested in that kind of stuff, I'd encourage you to, one, major in econ and go on to take a class like money and banking or monetary theory and policy, which I actually teach every fall. Okay, y'all have any other questions in about this? Okay, that's all I have. Test, I think I said test on Monday. I'm still totally confused by my schedule. Your test is next, this is a Tuesday, Thursday class, right? Your test will be next Tuesday, an hour and 15 minutes. I've already talked to you guys about the structure of that test. Let me just make kind of one other quick announcement about it, and this is also for the folks who are tuning in remotely. I really am trying to be accommodative with the attendance this semester for the obvious reasons, okay? But when it comes to the test, I want you guys and all of you guys that are here remotely, to the best of your ability, to make it to class, to take the exam in the classroom, okay? So unless you have COVID-19 or you're being forced to quarantine because you've been exposed, I really want you guys to take the test in the classroom, all right? So with that said, I will see you next Tuesday.